Thank you so much for joining this session again, where we are continuing on Seaborn visualization. So it's been a wonderful experience. We've been together in the first session. So let's continue on this session and talk about matrix plots and what are all about. So on the matrix plots, actually, they are very essential when we are doing correlation of data. What do I mean? Let's take, for example, now when you are working in a bank and you are the data analyst in that bank. So I will a task you should find out why clients are closing their accounts in that bank. So maybe you may not understand the relationship between some other services and that bank. So what do? You make sure that you relate to every service. For example, kodi agadi amabanga treat and banji, my bank data amadane, the transaction, everything. You need to make sure that you are checking how are these data sets related. So you use a matrix plots. So we already know how to add the tips data and add the tips data in the first section. So I'm using the very same notebook, so I've already added it. But if you don't know how to add the tips data, I'll also show you in this case. So let's take a look example of how we can add the tips data. We say tips here, and let's say sns.load underscore data sheet, and in this we are learning the tips data. But I also want to add another data set about freights. So it's the same criteria. These data sets, you can go to Seaborn, you can go to Seaborn link, or I can say Seaborn directory or documentation, where you can find out these data sets. There are a lot of them. So let me just say freights and data. Let me add this so that we can see their correlation. So because I am online, it's going to be fast. Remember, you have to be online in order to get these data sets. So let's see if let's see the head of these data sets. If we have loaded them, yeah. So let's see the freights data set, and let's see. Yeah, we are good to go. We have them. So the tricky part about these correlation data sets is because they are matrix in nature. They have to be matrix in nature for you to visualize them. So what do I mean by that? Let's take a look at example. Let's put a variable called TC. We want the tips data set to be in a correlated format. So you know, Python is very cool because with a simple code you are able to do the correlation. So let's write here tips.co. Remember, these data sets are pandas data frames already, so they do access the same functionalities of a panda. So we have the correlation function here. You can see that to compute pairwise correlation of columns including null values. So you can see the examples here, methods and whatsoever. You can see the correlation, the Pearson values, the Kendall values. Yeah, if you are into numerical methods, you can appreciate these things. So if I say TC here, run, and let's show what TC is all about. Let's see. You can see this data has been put in a matrix function and they have correlated. It means we are seeing the relationship between this tip and the total bill in size. I will show you later on what this means. Now let's do the first matrix plot that we have been given in Seaborn. The first matrix plot is called heat map. Now how can we visualize this data in heat map? So we call SNS and the heat map function. It's as simple as that, guys. Then we put the correlated data frame called TC, and we are not the values to true, so that we should see the values on the board. And to add more on that, we need to add a C map, a color map, so that they should look cool, but it's optional. We can put a color map called Kubo. Seaborn has got predefined color maps. You can see the documentations in Jupyter Notebook or in Google Labs if you want, or even go to their documentation website. Let's learn this. And what we see here is called a heat map. Now you see diagonally it says 1 1 because tips and right here tips are related 1-to-1 ratio, and you will actually see here that 0.8 to its total bill and tips, they are related to 0.8, and you can see the values here, the total bill and the size, which makes sense that they are related, because there are some other people that are buying, for example, lots of food, or some people they are buying maybe lots of cheaper food, which makes sense because we can't hit maybe 1-to-1. And in 0.49 you can see the tip and the size here is 0.1 because people, they can buy large amounts of food, but however they are giving less tip. It makes sense by that. Let's continue to another type of visualization, which is pretty interesting. So remember, we have actually imported the flights data set, so we also need to put correlation, but correlation in this case we can actually put the correlation, also the pivot table, because pivot table is the best way of correlation in Excel. We also have that function right here to draw pivot tables. So let's see how we can do that in Python. So let's put this variable fp about flight pivot table. So let's put the dataset flights, not right. Then we add a method called pivot underscore table. Then inside that method it requires an index. So index in the side yomwe makanga the column yambirira ukudi tizichula jana. We want it to have months. So you can appreciate the difference between correlation and pivot table, because in pivot table you can be indicating according to funa ukalejan. That's right. Then you need to add columns. Columns in the line yaba mwamba kuti ndizichula jani. So it's the same as many babangira mu pandas much. So we need to add year. Let me remove the plus here. Then after that you need to show kudima values akhala jani. So let's add the values. Ndifuna ma values akhale the number of passengers. Let's run this. And let's go to FP and see what FP is all about. So you can see it makes sense. My month is my index, the year is my column header, and the values are the number of passengers. So you see, this is a huge data set. But matrix plots, the heat map actually helps us to see the visualization. So for example, if I say FP here and add a C map, a color map, so that they should look cool, and yeah. So if we say like this, as simple as this, and run, we can appreciate the visualization right here. So we can see month ya June and August anthu ambiri ankawera ndege in 1916. What does it mean? If you see here, it's 1949 ikukwera zaka zikukwera, and it makes sense kuti anthu ambiri they are preferring air transport, and mu August and July mukuoneka kuti muli magazi ambiri omwe akukwera yani ndege. Why? Because the nthawi ya summer in America, if I'm not mistaken, and people prefer to fly in summer because they know it's safer than entire winter where my thunders and whatsoever. So you can see now with the you'll be able to maybe stock yanu ya zinthu zoti mwina chakudya chanchani, increase it in these months according to the data set. So that's how cool it is. And also you can do cluster map. Now cluster map are very much important if you want to see the relationship of the data that you are working in. So cluster map, let's put sns.cluster map, and let's put the FP, the flight pivot table, and the C map. Let's put cool. Actually, you can put other map called seismic here. It's also like that. And let's learn this. Now it's as simple as straightforward. So let's see the cluster map. You see these lines, they are showing the relationship between these values depending on certain features. So you see right here on 1959 and 1960, and in July and August, you can appreciate that there is lots of red here because it also has got a scale light here. So make sure that you know the relationship, and we also see that there's a relationship right here on this 1960 and 1959. Even as we go upwards, you can see January in this kunabwera anthu. So you see the relationship right there. And also in 1968 anthu samapitako kakwera ndegeyo and whatsoever. So you can actually do some little bit of analytics and get to know what's happening to your business and or your company. Now we are done with matrix plots. We want now to learn how we can do grids. So grids are very important because you can remember last time we talked about subplots. So just take in mind that the grids is the same as that. Kunena kuti ma subplots in a sense. So let's talk about grids. So let me just say here grids. Let me learn this so that we can actually show kuti kupanga za grid right now. Now let me import another dataset called ILIS dataset. So let me just say SNS load data underscore dataset. And let me put ILIS. Now this dataset is very, very popular because people are using it for machine learning. Now it's very popular. So let's see the head as well once we import it. Now, why is it popular? Because it's very easy to know, because it's just simple species. I think there are 3 of them. If you want to see the number of species, you can just use the bracket notation here, species, and go to dot unique function to find the unique number of species. So there are 3 here. So you can use these values, the sepal, the petal, and whatsoever, to determine which species of the flower is. So it's very popular for that. Now on the grids, how we can plot grids, we have the first one called pair plot. Pair plot is a plot that actually helps us to analyze the whole data. So if I say here pair plot and just say ILIS, learning this, you see that it depending on the data set that you have, it's going to be slow or fast, and it actually gives you the relationship between these data sets. We have seen this before, so we will not dwell much on this, but it's a very simple way to visualize the whole data set. Now let's go to pair grid. Now pair grid is where some other stuff happens. And these stuffs are very good because in pair grid we can be able to access. Remember, I told you that Seaborn is made on top of matplotlib. We can actually access features of matplotlib in pair grid. Remember, this one we have done recently is called pair plot. Now we are in pair grid because it helps us to customize this. So let's put a variable called g, and let's say sns dot pair grid. So pair grid needs to start with a capital P and also capital G right here. And let's put the iris data. Now if I learn this, what you have, it's only the grid. Now let's say it learn, what you have is only the grid. It gives you the grid depending on the data set. There is no data right here. But how can you do that? You can just say g.map, and you can use the purity.scatter. The same thing we are doing with matplotlib. And let's see, you see, wow, we have an error right here. Purity is not defined. Okay, let's add matplotlib. Let's just say import matplotlib.pyplot as prt. Let's learn this. Wait for it. Right. So depending on the data, you see now we do have the visualization right here. So you can access the functions of matplotlib and whatnot from there. Now let's do a little bit of customization, because let's see the power of pair grid and see the customization that is installed for us, because we can actually customize the charts to our own liking. So let's see right here. Now let's just say we want a variable. So you need to learn this in the same. So let's just say pair grid here and put iris, and let's just say gmap, no, g. Now pay attention to this. We need to say g underscore diagonal, but you say diag, not map, because if you say map, you are learning the whole, you are customizing the whole, all the charts. But map diag, I want to customize the charts that are in the diagonal section. Now let me put the, say, sns.dist plot. Remember last time I was putting this plot on this, but this time around I'm putting this plot because they haven't updated the API of running this plot in the grids section. I don't know why. Now let's put g.map underscore upper. What do I want in the upper section of my chart? Let's put purity.scatter right here, so that we can see that we can add all of them. See, now the lower underscore, it makes sense, lower. We don't need to think twice on this one. And I just need to put sns.kde plot. So this one is the kernel density plot. Let's learn this. So depending on your system, it's going to be a little bit slower, but yeah, we'll see how we can get to know. So don't worry about this warning. I've already told you about, they haven't updated this yet, the dist plot, and you can see that's what it's saying. It's depreciated function and will be removed in the future, blah 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 and blah. Now the output here, now have you seen, because of my PC, the visualization has just, oh no, I thought it was my PC. Now you can see that on the upper section we have the scatter plot, the diagonal section we have the dist plot, and we have the KDE plot on the lower section. So that's how you can do a little bit of customization in Matplotlib. Now there's another grid called facet grid, which is very, very much important. Facet grid, because it actually helps us to customize and actually do a little bit of visualization. So let's say a variable called gsns.facet grid. Now inside that facet grid, it requires data, and that data, let's say tips. This one. Tips, and it requires columns, and the column should be time, and the row should be smoker. So this time and row smoker, it's found in the tips datasheet. So let's put smoker here. So we want to see the relationship between these values with respect to another value, because it requires you to map those outputs with another value. So in this case, in the facet grid, you can put the visualization that you want, and I want to put a histogram plot. So the short form is histoplot. Then you can put the column you want to relate to, so the total bill. The total underscore bill. Now let me just add KDE is equal to true and add them right here. Now let's see what is happening right here. You see on the first section it's saying smoker, yes, time lunch, total bill right here, because this is total bill at the end here. You can see anthu amabwera nthawi lunch ma smokers amakonda kudya between 10 and 20. So you can see 10 and 20 people, they are 10 here. So you can see the collection that alipo anthu 10 omwe amakonda kudya 20 US dollars mabill awo when there is lunch time and there are smokers. Ma smokers nthawi ya dinner amabwera ambiri, ndipo bill yawo imakhaso chapakatikati. So you can see ma smokers ambiri aoneka kuti amagula zo cheap in this time. So you can see the relationship right there. So you can also do because here it's just counting, but in histogram zikungotithandiza kutani kupanga count. So let me just copy here, so to show you that you can also add a second variable. Let me just put it right here, and let's change this to scatter for us to add another variable. Let me put here to purity scatter, because I want to show you that we can put variables. Because if I want to add another variable, I can just say tip here to see the number of tips and bills that they give my smokers are many, or when there is no smoker. And let's see kuti ma smoker ambiri sapereka matipi akuluakulu. Yeah, so that's it. That's what I can get from this, but you can add things that you want. But anyway, this has been interesting. Let's see each other into the last section of Seaborn and Matplotlib. So thank you very much for your time, and have a good day.